Welcome to qnawire.
Okay, so here we're going to say upwards is positive. And here we're trying to find the velocity at the bottom of the window for the toy, and then the velocity at launch. So we can say that if upwards is positive, the acceleration would simply be equal to g, which would be equal to negative 9.0 meters per second squared. And if this is the case, we can choose the ground to be the y final equals 0 meters. That would be the ground. And we need to just get an intermediate result in order to solve for the velocity at launch. So we can say that y, the y position of top of window, would be equal to the y position at the bottom of the window plus the velocity at the bottom of the window multiplied by the time it takes to pass the window, and then plus 1/2 g times t, the time it takes to pass the window, quantity squared. And so we can solve. So we can say that 10 meters equals 8.0 meters plus velocity at the bottom of the window times 0.15 seconds plus, rather we can do minus 4.9 times 0.15 seconds quantity squared. And so we can simply use the solve function on your TI 84, 85, or 89 in order to solve for the velocity at the bottom of the window. And this will equal 14.07 meters per second. So this is just an intermediate result. We needed to find this in order to find the velocity of launch. So now we can use the velocity at the bottom of the window in order to find the launch velocity, assuming that the launch velocity was, of course, at 0 meters. So we can say that velocity at the bottom of the window squared, which would again equal v final squared, essentially, would equal v at launch, so v initial squared plus 2g times delta y, or in this case, it'll be y bottom of window. And we can see that velocity at launch is going to be equal to the square root of the velocity of the bottom of window quantity squared minus, or rather we can simply say plus 2g times y at the bottom of the window rather, my apologies, it'll be minus, my apologies. Just realizing that. Close parentheses, all to the 1/2 power. And at this point now we can solve. So velocity at launch would be equal to the velocity we just found, so 14.07 meters per second quantity squared, plus 2 times 9.80 meters per second squared times 8.0 meters, all to the 1/2 power. We find that the velocity at launch is going to be equal to approximately 18.8 meters per second. This is our final answer. That is the end of, oh, my apologies. This is the velocity at launch. We need to find the maximum height. So last part, to find the maximum height, we find the velocity at max height quantity squared. This is going to equal velocity at launch squared plus 2 times A times y max, or rather g, y max minus y initial. We're going to say that we know the velocity at the maximum height is going to be 0 because it is always 0. So we can say that y max would be equal to y initial plus the velocity at, rather, we can say plus negative velocity at launch, quantity squared, divided by 2 times g. This is also going to equal 0 because we're starting from the ground, and we already, in the last part of the equation, we're actually switching our perspective, that the y initial would be at the ground level. So this would be equal to 0 meters. And this would be equal to negative 18.84 meters per second quantity squared divided by 2 times negative 9.80 meters per second squared. And we find that the y max would be 18.1 meters. So this would be the maximum height reached. That is the end of the solution. Thank you for watching.